Hello, so in today's video, we're going to look at some angle formulae for sine. So what you'll see in your formula book is you'll see that this formula there in this box will appear somewhere in your A-level maths formula book. So it's this formula here. So sine of A plus or minus B is equal to sine A times cos B plus or minus sine B cos A. So if we just kind of like extract two formulas from that, we get these two formulas here. So sine of A plus B, well, A and B are like two angles. So I'll just say that A and B are two real numbers. So you've got two angles that you're going to add together. So that's why these are called sum angle formulae, because you're taking the sum of angles. So sine of A plus B is actually equal to sine A cos B plus sine B cos A. And the reason why it's a plus sign instead of a negative sign is because the order in which you put this plus and minus sign does matter. So if the plus is on top here, then and if the plus is on top there, then the plus corresponds with the plus sign there. That's kind of how the notation works. And if you've got a minus sign on the bottom there and a minus sign on the bottom there, then the minus sign corresponds to the minus sign there. So hopefully that does make sense. But if that doesn't, you can leave a comment below and I can try and help out. So yeah, the first formula is this one here. And your second formula you can extract from this one in the formula book is this one. So sine of A take away B equals sine A cos B take away sine B cos A. So we're going to prove those formulas. I mean, this is in your formula book, so you don't necessarily have to learn this formula, but we're going to prove it because you do need to know about the geometric proof for how you prove these two formulas. So I'm just going to do a brief reminder. So let's say you've got a right angle triangle with an angle of theta there. So that means that if we take the sine of theta, so remember sine is opposite over hypotenuse. So I'll just call this the opposite side there, and I'll call this the adjacent side there. So sine is opposite over hypotenuse. So your opposite sine is your opposite. But in this triangle here, I'm just going to call the hypotenuse 1. If you do opposite divided by 1, you just get opposite. So in fact, this opposite side here is just sine theta. And the adjacent side, very, very similar down here. Your adjacent side divided by hypotenuse is cos, and adjacent divided by hypotenuse of 1 just gives you adjacent. So your adjacent side is cos theta. So this equals cos theta here. So that's going to be helpful with these proofs. So we'll start off by proving the first one, the sum formula, where you add the two angles together. We're going to start with that one first. So the way you do this is you're going to make a right angle triangle on the bottom down here, and you're going to call the angle there A, and then you're going to like chuck on another right angle triangle with an angle B here and put the right angles there and there. And you're going to call the hypotenuse with this top triangle with the angle B there, you're going to call that hypotenuse 1. So that means that using this fact that we did here, so it means that we can fill in some lengths. So we know that this adjacent side to the angle, to this like top triangle, that's going to be cos B. Let's do this in red. So that's cos B there. And this side up there is going to be sine. Let me actually do it over here instead. So sine B is that side there. What I'm actually going to do now is I'm just going to draw like a box, like a rectangular box around these triangles, and you'll see why I'm doing this in a minute. So we've got that. Now let's think about what we actually want to prove. So we want to find a formula for sine of A plus B. That's kind of what we want to, that's the objective. We want to try and get a formula for sine A plus B. So let's go back to our diagram. So we know that the angle here is A, and obviously that's B. So if you add those together, that's going to be an angle of A plus B. So we want to calculate sine of A plus B. Now let's think about this. We've got a line up here parallel to a line down there. So we've got parallel lines. So using alternate angles, we know that this angle there is the same as this angle there, because you've got parallel lines. You've got kind of like the Z angles going on to alternate angles. So this angle up here, if I just get rid of these red lines, this angle there is going to be A plus B. So you've kind of got a right angle triangle here with a hypotenuse of 1 again, still the same hypotenuse, and an angle of A plus B. So remember the adjacent, so if you've got a hypotenuse of 1, the adjacent side is cos of A plus B. So that's cos A plus B. And your opposite side is sine of your angle, so sine A plus B. Okay, so we're trying to work out, the proof wants us to work out this, sine A plus B. Now we know that the height of this rectangle is sine A plus B, we know that. So if we can work out this side here and add it onto this side here, then we get sine A plus B. So that's kind of the objective with this proof here. So let's start off by filling in some more angles on the diagram. So we know that this is angle A here, this like angle down here. This is a 90-degree triangle or right angle there. So we know that this angle there is going to be, well, all angles in a triangle add up to 180. A plus 90 is A plus 90. 180 take away that angle leaves us with an angle of 90 minus A there. Now, angles on a straight line here add up to 180. You've got 90 already there. So 90 plus 90 minus A plus some angle gives you 180. This angle here must be A. Okay, so we've got a tiny little right angle triangle up here. Let me do this in pink. So we've got like a tiny little right angle triangle there. You've got a hypotenuse of sine B, because we just worked that out. You've got an angle there of A. We want to kind of find this adjacent side. So remember, adjacent hypotenuse, that's cos. So let's just make a note of this, that cos of, I mean, if I just call this side there x. So cos of A is equal to the adjacent x divided by this hypotenuse sine of B. So therefore, that means that x is equal to sine B times by cos A. So we can actually just fill this in here. So sine B times by cos A. So that's our x there. Now let's try and work out this side here. So we'll call this y this time. So we'll call that y. So again, we've got a right angle triangle. We've got a hypotenuse on this bottom right angle triangle of cos B, and we want to find the opposite side. So this is opposite hypotenuse, that's sine. So we want to do sine A for this angle there equals the opposite y divided by the hypotenuse, which is cos B for this triangle. And so therefore, y is equal to sine A times by cos B. And so for, yeah, this is sine A times by cos B. And so therefore, sine of A plus B, this height here, is equal to that plus that. And that is exactly what the formula tells us. So if we just move everything up a little bit to get some more space. So therefore, we can conclude that sine of A plus B is equal to sine A times cos B, and then plus sine B times cos A. So that's the first formula proved. So we've done number one, got that formula there. Now let's go to number two, prove the second one here. So this one's a little bit different in terms of the setup. I mean, it's a similar kind of thing, but this time what we're going to do is, instead of this one here where we put like two right angle triangles on top of each other, we're going to like kind of like mesh two right angle triangles together. So we're going to have a right angle triangle upside down, this one up here, and we're going to have one like flat like this on the bottom here. So what we're going to do is we're going to call the angle here B, this like blue angle there, and we're going to call the entire angle there A, this hypotenuse in the middle there 1. So that means that this tiny angle down here is going to be A take away B, because the big angle there is A, you've got B taken up there, so the remaining part, this remaining little bit there, is A minus B. So we'll just make a note of that. Again, we just want to draw in like a box because that's going to help us out with our calculation. So with this one, we're interested in calculating for the proof of the second formula. We want to try and get a formula for sine of A take away B. So let's think about how we could do this. So again, what I'm going to do is just fill in what we know. So we know that we've got a hypotenuse there with this bottom triangle of 1. We've got an angle down there of A minus B. So the adjacent side is going to be cos of A minus B. Again, I know that by using this reminder that we started with today. The adjacent to an angle, when you have a hypotenuse of 1, is just cos of that angle. And similar with this side over here, this side over there is sine of A take away B. Now we want to calculate sine of A take away B. So I guess, again, it's going to be similar to this previous proof where we want to work out this height, we want to work out this height, and this height, and we want to do the big height, take away this one there to leave us with sine A minus B. So that's kind of the idea with this proof. So you got sine A minus B there. Now let's think about what we've got going on here then. So this upside down right angle triangle here, hypotenuse of 1. Now the angle there is B, so the adjacent there is this. So the adjacent to B is this side here. So this is going to be cos B there. So this like length there is cos B, and the opposite up here is going to be sine B. So the opposite side there is sine B. Okay, so we know that. Again, let's think about our angles. So similar to like this previous one here, the using alternate angles, this angle was A plus B when this angle was A plus B. Now this angle here is A instead, so that angle up there is going to be A. So again, we've got a right angle triangle here, this kind of right angle triangle up here. So we've got a hypotenuse of cos B. We've got a opposite side here of an unknown number. I'll just call it x again. So we know that sine of A, this A over there, is equal to the opposite side x divided by the hypotenuse cos B. So we can say that x is equal to sine A times by cos B. So let's just make a note of this here, that x equals sine A times by cos B. So this height here, again, I'll do this in pink, is sine A times by cos B. So that's our height of our entire thing. And we know that this height from there to there is sine A minus B. We just really need to find out what this height from there to there is going to be. That's kind of what we need to do now. So how could we do that? So we've got, again, a right angle triangle there, a hypotenuse of sine B, because we know that that side there is sine B. So let's think about the angles that we've got. So we've got an angle here. Well, we know the angle down there is A minus B. It's a right angle triangle. Angles in a triangle add up to 180. So 180 take away 90 gives 90. And then 90 take away this angle down here is going to give us 90 minus A plus B inside there. Now then, what's this angle here going to be? So you've got 90 degrees here in this triangle. You've got B there. And remember, angles in a triangle again add up to 180. So 180 take away 90, take away B. That's going to give us 90 minus B inside there. So then again, angles on this straight line add up to 180. So 180 take away this angle, take away this angle, we're actually going to be left with A. So that is going to be A. So if you do A plus 90 minus B plus 90 minus A plus B, you get 180 degrees. So you've got a right angle triangle with A degrees there, hypotenuse side B. To get this adjacent side, if we just call this, let's call it Y. So adjacent hypotenuse, that's to do with cos. So cos of A is the adjacent Y divided by the hypotenuse sine B. And so therefore, Y is equal to sine B times by cos of A. And so, yeah, we know that this here, again, is sine, like this length going from there to that, is sine B cos A. And so therefore, we know for a fact using this diagram, if we just again make the diagram smaller, we know that, again, the pen back, there we go. So we know for a fact that this sine of, let me do this in different color actually. Let me do it in green. So we know that sine of A times cos B, so like this big side from there down to there, is equal to sine of A minus B, so this side from there to there, plus this sine B times cos A. Okay, so we know that. And then again, the proof wants us to get sine A minus B, the subject to the formula. So we're just going to, we're just going to take away this sine A, sorry, this sine B times cos A. So therefore we get sine of A minus B is equal to sine of A times by cos B, take away sine B times by cos A, and that is exactly the formula that we wanted to get. So yeah, that's how you would prove that second identity. And yeah, you just need to know roughly how you prove these identities using this kind of geometrical argument. I'm just going to try and make my writing smaller. There we go. So we get, yeah, this result down here, and that is the proof done. So yeah, that was just a summary of how you can prove these two identities using these kind of geometrical arguments. So you're not going to be asked to prove these kind of things straight away. They're not going to say to you in the exam, oh, go and prove that sine A plus B is sine A times cos B plus sine B times cos A. They're not going to say that straight away. They may guide you through a problem where they kind of get you to do this in a step-by-step question. So as long as you're aware of how to do this, that's the most important thing. So yeah, that's how you would prove these two identities. And again, you get this formula in your formula book, so you can use this formula here to do calculations with the sum of angles within the sine function.